April was a normal child who attended school and always had excellent grades, a perfect student. She was also active, loved playing volleyball and hanging out with her friends. During her teenage years, she was very energetic and helped her father with the properties he rented out. She repaired doors, roofs, and even installed wiring. She also helped manage the properties by collecting rent and meticulously keeping track of the business finances. This skill with numbers helped her graduate with honors from high school and easily get into the accounting program at the University of Maryland, where she continued to excel academically, had many friends, and loved life. Everything was perfect until one phone call changed her life. Her parents answered the phone to hear from a professor that April was acting erratically and had been hospitalized. The details were unclear, but it seemed something traumatic had happened to April. The Washington Post, the original newspaper that published this story, kept April's privacy about exactly what happened that day in 1995 when she was just 21 years old. What we do know is that from that traumatic experience, April was never the same. She began experiencing auditory and visual hallucinations that eventually led to psychosis. April was diagnosed with severe schizophrenia, a serious psychiatric condition that affects 1 in 300 adults worldwide. People with schizophrenia often lose the shared sense of reality with others and see the world in a distorted way. The symptoms of schizophrenia can vary from person to person, but range from hallucinations, delusions, thought disorders, memory and concentration problems, loss of motivation, disinterest in daily activities, difficulty showing emotions, and withdrawal from social life. Again, the presence of one or more of these symptoms varies from person to person and with the progression of the disease. Schizophrenia is a complex condition that we have yet to decipher. We know risk factors, but we don't have a defined cause. Like other complex diseases, its cause seems to be the interaction of multiple factors that can be genetic, chemical, and environmental. For example, while schizophrenia has a genetic basis, it is not inherited in a simple or direct manner. Many different genes have been identified that may increase the risk of schizophrenia, but there are people with schizophrenia who do not have these genes, and people with these risk genes who never develop the disease. We also do not fully understand how it affects the mental functions of those who suffer from it, although we know it involves alterations to the brain's structure and chemistry. Due to these gaps in our understanding, we have treatments that can reduce symptoms to some extent but have not found a cure. April became incapable of taking care of herself. She couldn't bathe, dress, or eat on her own and required 24-hour care. This became too much for her family. In 2000, 5 years after her first episode, April was admitted to the Pilgrim Psychiatric Center for long-term care. The family tried to stay close to her, but April was trapped in her psychosis. She didn't recognize her parents or siblings, didn't speak to them, and any physical contact, like hugs, kisses, or even a light touch, agitated her. April spent her days frozen, unmoving, not speaking, lost inside her head. Although sometimes she seemed to be doing mental calculations with her fingers and talking to herself about financial transactions, her basic needs were attended to by the psychiatric center staff, who had to maneuver her like a mannequin due to her constant catatonic state. This is called waxy flexibility, a symptom of catatonic schizophrenia that leads to a reduced response to stimuli and a tendency to remain in an immobile posture, keeping limbs enforced, uncomfortable, and even anti-gravitational positions imposed by the examiner. The patient can stay in the position they are placed in 4 minutes or hours, and the return to a resting posture happens slowly. April's life had turned into this, her physical body almost an inanimate object while her mind was enveloped by psychosis. For 20 years, she underwent various treatments without results, taking antipsychotics, mood stabilizers, and even electroconvulsive therapy ECT. Don't imagine anything crazy. The days of electrocuting people as if they were hanging from a pole are over. Today, ECT looks like this. The treatment involves sending an electric current through the brain, causing a brief increase in electrical activity and the release of neurotransmitters. This is known as a seizure. Yes, the body is convulsing, but muscle relaxants or anesthesia are administered to the patient to avoid the violent movements that occurred during the seizure, which in the past often left patients with serious injuries like fractures in limbs or even the spine. ECT is considered one of the last resorts for people who do not respond to other treatments and is used for patients with schizophrenia, severe depression, and obsessive-compulsive disorders. As a curious fact, in Mexico, the procedure is supervised by the National Human Rights Commission. The Pilgrim Psychiatric Center, where April was, housed some of the most severe psychiatric cases in New York State. It was there that Dr. Sandra Marks found her. Dr. Sanders is the director of the Precision Psychiatry Department at Columbia University. Precision psychiatry uses a flowchart procedure to diagnose patients, starting with an extensive phenotypic characterization of the patient. This basically means observing their physical behavior and symptoms. The next step is more revolutionary, a comprehensive evaluation of the patient's genetic mutations. These genetic results are investigated using different models to identify the patterns and mechanisms that generate the observed phenotype, meaning they look at the genetic origin of what is expressed as a pathology. Finally, the relevant clinical biomarkers for the patient are evaluated to understand the patient's overall health status and whether they might have another condition in addition to the psychiatric problem being addressed. After this entire process, different medications that are promising for restoring normal neuronal function are evaluated, making a perfect match between a detailed genetic and phenotypic profile of the patient and the best treatment available. Hence the term precision in precision psychiatry. To understand what was happening to April, Dr. Sandra Marks assembled a team of 70 specialists worldwide, including neurologists, neuropsychiatrists, neuroimmunologists, rheumatologists, and others. He also obtained the family's authorization to perform all the tests mentioned. The first red flag was raised with her blood tests, which showed that her immune system was producing very high amounts of antibodies that were attacking her body, specifically her brain. Thanks to MRI scans, it was discovered that these antibodies were attacking April's temporal lobes, areas associated with schizophrenia and psychosis. As you might guess, the team hypothesized that the antibodies might have altered the receptors that bind to glutamate, disrupting how neurons communicate. The final diagnosis: April had lupus. Lupus is an autoimmune disease in which the body's immune system, which normally defends us from infections and diseases, begins attacking and destroying our healthy cells. In simple terms, two things happen in autoimmune diseases. First, the immune system becomes hyperactive, like a child who doesn't know what to do and starts breaking things. Second, it loses a very basic and fundamental capability for its functioning, the ability to distinguish between self and non-self. Imagine hiring a guard to protect your house, and suddenly this guard forgets who you are, so they can't tell if a burglar is trying to enter or if it's you coming home from work. This guard is also very temperamental, so out of nowhere, they pull a gun on you. This is exactly what our immune system does. It can't distinguish between our tissues and foreign ones. So it does the only thing it knows to do: try to defend us by producing antibodies that attack our cells. The attack can be systemic, indiscriminately damaging organs, or targeted at a specific tissue perceived as foreign. Besides antibodies, other immune cells can cause inflammation and damage to tissues and organs, leading to a variety of symptoms depending on which parts of the body are being attacked and their severity. April's lupus was attacking only her brain. For April, having lupus wasn't evident since the rest of her body didn't show any other symptoms. It was neuropsychiatric lupus, which affects around half of lupus patients. The scientists finally had a suspect, and an autoimmune disease like neuropsychiatric lupus has a specific biological mechanism that can be treated. The medical team began an intensive immunotherapy treatment consisting of high doses of intravenous steroids for 5 days, plus a dose of cyclophosphamide, a strong immunosuppressant used in chemotherapy. As you can imagine, this cocktail is extremely heavy on the body, so April needed a month's rest between treatments. Now, if you've made it this far in the story, this is where we all hug and cry, and then go celebrate. This, my friends, is the wonder of scientific advancement. It's the kind of news that brings tears to my eyes. The 3 images I'm going to show you summarize decades of research and advancements in neurology, psychiatry, genetics, immunology, and the work of thousands of people dedicated to human well-being. The first image gives us a glimpse into April's mind before the treatment. This is part of her Montreal Cognitive Assessment, an exam used to evaluate the cognitive ability of patients. During the evaluation, patients are asked to perform different tasks, one of which includes drawing a clock. April's response before the treatment was a set of nonsensical scribbles, confirming her state of dementia. After the first round of steroids and immunosuppressants aimed at reducing the attack of her immune system on her brain, this was April's result. This is a marvel. We still don't see a clock, but it's starting to become evident that the idea is surfacing. There's already a perimeter that defines the object, and although the rest of the elements are still confused and undefined, you can see there's more order in the individual's mind. And now, the clock April drew after the 3rd round of treatment. This, my friends, makes me want to cry. Somehow, I feel the mental tranquility the individual must feel at this moment. The first clocks convey her anguish. It pains me to think of the person's mind struggling to untangle a black cloud without succeeding. But in this 3rd clock, a perfect clock that any of us could have drawn, I sense that the mind finally managed to untangle the black cloud and emerge to see the light. The treatment was working. By 2020, April was considered mentally competent and was discharged from the psychiatric hospital where she had lived for nearly 2 decades to move to a rehabilitation center. After the COVID restrictions were lifted, April was able to reunite with her family in person. According to the Washington Post article in the reunion video, April still looked doubtful and fragile, but she could remember her family members, even mentioning, "You lost your hair," when she saw her father again. The family recounts that she could remember their childhood home in Baltimore, her school grades, being a godmother at her brother's wedding, apparently everything up to when the autoimmune disease started attacking her brain. These news stories are the beauty of living in this era full of scientific advancements, and possibly the best thing I'll see this week. April's recovery is slow, and she will continue rehabilitation, gradually improving her condition. Her case, and the successful treatments of others, are a beacon of hope for many still in mental institutions. At the publication of the original article, 200 patients with autoimmune diseases had been identified in mental institutions in New York State alone. These 200 people might soon emerge from the darkness they are in. Similarly, scientists in Germany and England are conducting similar research pointing to the interaction of autoimmune diseases in various psychiatric conditions. While current research will probably only help a small group of patients remember that schizophrenia and other psychiatric conditions are multifactorial and not all are related to autoimmune diseases still, the impact of this work is already changing the lives of hundreds of people and also transforming the practice of psychiatry and the way many mental illnesses are diagnosed and treated.